Hello everyone, welcome to MES e-learning channel. In this video we will be discussing about unity feedback system. So here we have a question where they have given an equation and they have asked us to determine type of the system, static error coefficients and the error for RAM input of magnitude 4. Okay. So since it is a unity feedback system, unity means 1, correct. So since the system is a unity feedback system, okay, let's start solving. We can say that since the system is a unity feedback system, what is used to denote feedback? Feedback is denoted by H of S, correct. So, H of S is equal to 1 and a unity is what? Unity means 1, that is why we got H of S is equal to 1. Hence, we can say that the open loop transfer function, right, which is G of S, H of S is equal to what? G of S over here, that is 40 into S plus 2 upon this thing, right, into 1. So, you can simply write this term, correct. So, the first thing that we have to determine is type of the function, type of the system. So, type of the system, it is what? It is the power associated with the single s in the denominator of the transfer function, correct. So, what is the power associated with s, or we can say that the number of poles at origin. So, it is what? It is 1. What is the power of the s that we have here, single s that we have? It is 1. Therefore, we can say that type of system is equal to 1, correct. You can also write that the power associated with single s in denominator is 1. Okay. So, let us move ahead and find out the static error coefficients. Okay, so what all are the static error coefficients? We have 3 static error coefficients. We have Kp, we have Kv and Ka. Kp is positional error coefficient, Kv is velocity error coefficient and Ka is acceleration error coefficient. So, all these 3 static error coefficients can be calculated using the formula. So, Kp is equal to limit s tends to 0 g of s into h of s. Okay. So, we already have this with us, correct, g of s h of s equation we have with us. So, let us substitute it over here. So, after doing that, we have this. So, now if you substitute s as 0 in this particular equation, what will happen? You will get the value as infinity, correct. So, what is the value of Kp? Kp is infinite. Let us move ahead and find the value of Kv. Kv is limit s tends to 0 s into g of s h of s. So, this is the formula that you have to remember. Now, let us substitute the value of g of s h of s is in this particular formula. After doing that, we have this s plus 2 upon s plus 1 s plus 4. Now, this s and this s will get cancelled and then you will have what? You will also substitute s as 0 in this equation. So, you will have 40 into 0 plus 2 upon 0 plus 1, 0 plus 4. When you simplify this equation, the answer that you will get is 20. Hence, kV is equal to what? kV is equal to 20. Now, let us calculate the value of Ka, that is acceleration error coefficient. So, Ka is limit s tends to 0, s square into g of s h of s. Okay. So, this is the formula that you will have to memorize. So, let us substitute the value of g of s, h of s that we have in this equation. After doing that, this is what we will get. So, this s and the square will go, and then we will also substitute the value of s as 0 in this equation. So, after doing that, what we will get? We will get have this particular updated equation, and once we put s as 0 over here, 0 multiplied with this equation will give us 0 as answer. Hence, we can say Ka is equal to 0. So, we have calculated the static error coefficients Kp, Kv and Ka. Now, last part of the question was error for ramp input of magnitude 4. Let us solve that. So, we are calculating error for ramp input of magnitude 4. So, they have given us the magnitude is denoted by A, okay, and what is the input that we have? It is a ramp input, okay. So, when ramp input is applied to the system, then velocity error coefficient, that is Kv, will control the error. Therefore, so you can say that ESS, that is the static error coefficient, okay, steady state error coefficient is equal to A upon Kv. So, A is already known to us, it is 4, that is given here, okay. So, 4 upon Kv. Kv we have already calculated and we know it is 20. So, we have 1 by 5, that is 0.2 as answer. So, the steady state error ESS is 0.2. So, I hope you have understood. Thank you for watching.